Alright, and we're going to begin with some warm-up problems that deal with solving equations. These are some algebra equations that you might have learned in Math 130 or Math 140. So the first one is a linear equation, and we're solving for y. When we have a constant term, we just subtract it from both sides, and that'll give us 2y is equal to -1. Then we would divide by 2 both sides of the equation, and we would get y is equal to -1/2. Then there's always a way that we can verify whether we have the correct answer or not. That's by taking the solution and plugging it back into the original equation and checking to see if it makes it true. Okay, so if we replace the y with -1/2, is it true that 2 times -1/2 plus 1 is going to be equal to 0? Well, this is going to give us a -1 plus 1. Is that equal to 0? And the answer is yes. -1 plus 1 does equal 0. So that means that our solution here is correct. All right. Now for part B, we have a quadratic equation. There are 3 possible ways that you can solve a quadratic equation. You can use the quadratic formula, you can complete the square, or you can try to factor if it's factorable. So in this case, I'm going to try to use the factorization method. And there, again, maybe you learned it a different way. Whatever you feel the most comfortable with, that's what you should use. For my students, what I do is I ask them to look for 2 numbers that are going to multiply to, first of all, the constant term. So they're going to multiply to -2. And they're going to add up to the coefficient of the linear term, or the coefficient of the term that is just y. So that would be that add up to 1. And in this case, we are able to find 2 numbers that satisfy this. We have 2 and -1, right? 2 times -1 gives us -2, and then 2 plus -1 gives us 1. So that means that this equation, or at least the left-hand side, can be factored into y plus 2 times y minus 1, and then that is equal to 0. And again, you can always verify just by distributing back in. If we have y times y, we'll get y squared. Y times -1 would give us -y. And then 2 times y would give us a positive 2y. So -y plus 2y, that would give us 1y, which is this term. And then finally, 2 times -1 would give us -2. Okay, so just a quick visual verification that they're the same. Okay. From there, we use the zero product principle. And what that means is that if you have 2 numbers, let's just say like a times b, and it gives you 0, the only way that that can happen is if either a is equal to 0 or b is equal to 0, or maybe both. Okay, but you can't multiply 2 things together and get 0 unless one of them, at least one of them, is 0. And so that's the case here, right? We're multiplying these 2 expressions and we're getting 0. That means that at least one of them has to be 0. And then we have something that's linear, something that we can solve by subtracting the constant of each on each side. So in this case, we're going to get y is equal to -2. And in this case, we're going to get y is equal to 1 by adding a 1 to both sides. So we get 2 answers. And again, you can always verify by plugging these back into the original equation. And just for the sake of time, I'll go ahead and leave the verification up to you guys. We have one more equation. And sorry, I haven't asked. Do you guys have any questions? Yeah. Always feel free to stop me or interject if you have any questions. There's this part C that has x times y is equal to x. And I'll start off by telling you what not to do. be careful that you don't see x on both sides and you think, oh, well, I can divide both sides by x. Because we don't know if x might be 0. And if x is 0, dividing by 0 is not allowed. Okay, so I'm just going to write here a quick statement. I'm going to say, careful, do not divide by 0. Oh, sorry, do not divide by x. Okay. And then I'll write, because we don't know if x is 0. And if x is 0, then dividing by 0 is not allowed. Right, so then what do we do if we cannot divide by x? Well, instead, a good idea would be to subtract the x from both sides. Okay? And so what that is going to do is create an equation that looks like x times y minus x is equal to 0, because on the right-hand side, these are going to cancel out. And now that we have x present in both terms, we can factor it out. And that would leave us with a y in the first term and a 1 in the second. We get x times y minus 1 is 0. And now the same as before, if you have two things multiplying to 0, that means that at least one of them has to be 0. All right, so first one's already isolated, x is already isolated. The second one, we can add a 1 to both sides to get y is equal to 1. And now I'm just going to check for this because we do have an equation that perhaps we haven't seen before. So I'm going to check by plugging in the x equals 0 first. So this for x is equal to 0. Is it true that 0 times y is equal to 0? Okay, just by replacing these in. Well, the answer is yes, right? 0, y can be anything, and 0 times anything is going to be 0. So here we're going to get 0 equals 0, which is correct, which is a true statement. So this is correct. Next, we're going to check y is equal to 1. And so if we replace it into the original equation, we'll get x times 1. And is it true that that'll equal to x? And well, that's also true because x times 1 will just be x, and x is always equal to itself. Right? So we get a statement that reads x is equal to x. That's also true. So this is also a correct solution. All right. That was a warm-up, no trig involved in there, but I do find it helpful to look at this, these algebra steps that we probably haven't practiced too often recently. Let's take a look at example 5a, where we have an equation that does have a trigonometric function in it. We have 2 sine theta plus 1 is equal to 0. And they want us to find all of the solutions over the interval 0 to 360. And so before we even attempt, let's look at what this means. We have a bracket next to the 0 and a parenthesis next to the 360. Bracket next to 0 means that the 0 can be a solution. It means it's included. If we were to draw it on the number line, and let's say this is 0 degrees and 360 is somewhere over here, that means that we would draw a closed circle by the 0 degrees and say it's all of the numbers between 0 and 360, but not including the 360. So it'd be open circle there. So that's all the range of numbers that we can consider. All right, so looking at this, it's actually very similar. The algebra portion of it is going to be just like what we had for the first warm-up, the 2y plus 1 equals 0. Because if sine were to be y, we would have 2y plus 1 equals 0. Okay, so let's go through the work then. The first thing that we would do is subtract a 1 from both sides. and we would get 2 sine theta equals -1. Then we would divide by 2 both sides, right? Because that's equivalent of having this step. So then we would divide by 2 both sides, and we would get sine of theta is equal to -1/2. So up to there, just algebra. Now comes the trick portion. What is this asking? This is asking what angles theta have a sine that is -1/2 in the range 0 to 360. Let me bring out the unit circle. And you guys help me out here. Where is sine -1/2? First of all, where is it negative? Which quadrant? So because sine deals with the y-axis, negative would mean in this downwards direction. That would mean we're looking at quadrant number 3 and quadrant number 4. And then where is sine -1/2? What angles do you see there? Sorry, I see. Manila, I can hear you, but very faintly.
Oh, sorry. Hold on.
What's up, Manila?
Quadrant
210 and 330.
Yeah, very good. 210 and 330. So at 210, let's look at what the cosine is. And remember, the cosine is always the y coordinate. So it's -1/2. And then at 330, we also have -1/2. Good. Okay. So that means that for answers here, we have 2 possibilities, 210 or 330. Right, now we can check the same way that we did, the same way that we checked for just the algebra equations by plugging back into the original expression. So we're going to take the 210 degrees and plug it in and check, is it true that if I have 2 times sine of 210 degrees plus 1, that that'll equal to 0? Well, we saw from the unit circle, right? Sine of 210 is -1/2. So is it true that 2 times -1/2 plus 1 is going to be equal to 0? Then we're going to get -1 plus 1 equals 0, and 0 equals 0, which is correct. So this 210 is correct. And then you would check 330 the same exact way. You're going to get a true statement. Again, for the sake of time, I won't do it, but you can check it and you'll see that this one is also correct. So you can either leave your answer in this way, or in the homework, they're going to ask you to identify the solution set. Okay, so the solution set simply means that we list out all of the correct answers inside of curly braces. So it would mean the 210 and 330. Right, questions here? Okay.
Professor, can you see the last part?
Yeah, of course.
Just the last part.
Now part B is asking, oh, it has the same
Thank you.
exact, yeah, no problem. Has the same exact equation, but the interval that they're asking over is not 0 to 360 anymore. They're telling us for all solutions, right? So If we take a look at the unit circle and try to think about what that means, they're asking for all of the angles that are going to satisfy this, meaning we're trying to see what are all of the angles that are going to give us sine of theta is equal to -1/2. And so in just this range 0 to 360, meaning in one cycle, we saw that the angles would be 210 and 330. But if we were to consider more than one cycle, so let's say I complete the 360 and decide to go 210 more, it would give me an angle that's coterminal to 210, right? It would give me 210 plus 360. And that would also have a sine of -1/2, which means that this angle, which turns out to be 570, would also be a solution to the equation. And not only that one, but basically anything that's coterminal. So we could do like 360 times 2. That means complete 2 cycles and then go to 210. And that would also be coterminal, which means it would also have a sine of -1/2. 210 plus 360 times 3. Any number of cycles added to 210 would satisfy. The same is true about 330. If we look at an angle that just completes the full cycle and then goes 330 more, meaning we would have 330 plus 360, that would be coterminal, giving us the same sine value of -1/2. So to answer this question, what are all the solutions? Well, it would be 210 plus any multiple of 360, meaning plus any number of cycles. So it could be 0, plus or minus 1, plus or minus 2, or any other integer. And the same with 330. It would be 330 plus 360 times n, where n is representing the number of cycles. Okay. Those are the answers, and then I'll write the reason why. I'll say this is because these expressions describe all angles that are coterminal to 210 and 330 respectively. So hence, all these angles satisfy that sine of theta is equal to -1/2. Oh, I'm sorry. Yes, thank you, Nana. I'm just seeing your message. We're using it. Okay. And so you can leave your answers like this, but just so that you get accustomed to writing it as a solution set. I'm sorry, guys. I'm going to take care of the background noise. So the second way to write it is as a solution set, which is what you'll see on the homework. And so the solution set is write these answers in a list in between curly braces. So the first one would be 210 plus 360n and 330 plus 360n, and then we're going to write a separating bar where n can be 0, plus or minus 1, plus or minus 2, or any other integer. Questions there? The part C is a little tricky. It might seem a little tricky, but the algebra aspect of it was actually already done in the warm-up. And so how so? Well, let's pretend that x is representing sine. Okay, so we have a sine there and a sine on the right-hand side of the equation. And then we'll let tangent be y. So then what this is saying is that x times y is equal to x. We solved this equation and it was C from the warm-up, right? X times y is equal to x. And so algebraically, what we did was subtract the x from both sides. So in our case, that would mean subtract the sine from both sides. And we're going to get sine of theta times tangent theta minus sine theta is equal to 0. And then if we compare against just the algebra problem, so that would be like this first step, right? What we've done here, subtract the sine from both sides. The next thing that we did was, because x was found in both terms, we factored it out. So here, sine is found in both terms, so we're going to factor it out. That'll leave tangent theta by itself for the first term minus 1 for the second term is equal to 0. So that's like this step here. And then we use the zero product principle, where either the first term has to equal to 0, the first factor has to be 0, or the second factor has to be 0, the tangent theta minus 1. Right, so this term, the trig function is isolated already. In this term, we would have to add a 1 to both sides. So we would get tangent theta equals 1. And now we have the trig aspect that comes into play, because all of this was just algebra. Now comes the trig aspect. This is asking what angles, will focus on the first equation, what angles satisfy that sine of the angle is 0 in one cycle, 0 to 360. So again, look at the unit circle. Where do we see sine being 0? Good, very good. So 360 would be at one location. So at 360, we see that the y is 0. We just have to be careful about how we write this answer, because with the range that they gave us, they told us that we can include the 0, but not the 360, right? So we would need to write it as 0 instead of 360. So one of them is at 0 degrees. And then, yep, thank you, very good, Manal. So then the second one would be at 180. That's where we also see sine being 0. Good. Okay, so theta is equal to 0, or if theta is equal to 180. What about for tangent? So we're done with the sine, right? Those are the only two places where sine is equal to 0 in one cycle. What about for tangent? Where is tangent equal to 1? To help us out, let's remember what is tangent of theta on the unit circle. It's going to be y over x. And this is something that we saw in the first unit. It's always given as y over x. So if this is supposed to be equal to 1, that means that both the y and the x need to be exactly the same value. So what angles have a y and x or correspond to a y and x with exactly the same values?
315 and 45.
315 and 45. Okay, so 315, we want to be careful because this one is positive, this one's positive, and this one's negative. But 45 is, that one does apply because we do have x and y being the same. So one of them would be the 45 degrees. What would the other one be?
225.
225, very good. Yeah, 225. Because there the x and the y are both negative radical 2 over 2. Very good. Okay, so then we can bring those answers back to our paper. We've got 45 degrees, and theta equals 225. Now again, it's a good idea to check. I won't check all 4 answers, but I will check one from each. So let's check 0. We have sine of 0. Is it true that sine of 0 degrees times tangent of 0 degrees is going to be equal to sine of 0 degrees? Well, sine of 0 degrees is 0. Tangent of 0 degrees, so here's 0. Tangent would be y over x, or 0 over 1. 0 over 1 is also 0. So is it true that 0 times 0 equals 0? Well, yes. 0 does equal 0. That means that this answer is correct. You can do the same work for 180. I won't do it for the sake of time, but we'll see that 180 is also correct. Let's check 45 degrees. I guess I'll do it here. Check. Theta equals 45. And we'll plug it in. Is it true that sine of 45 degrees times tangent of 45 degrees is equal to sine of 45 degrees? Well, we just completed the tangent part, right? We saw that tangent of 45 is equal to 1 because the y and the x are both the same. So that means that this is 1. So is it true that sine of 45 degrees times 1 is equal to sine of 45 degrees? Well, yeah, that is true. In fact, we could just replace what sine of 45 is. It's going to be radical 2 over 2. So radical 2 over 2 times 1 does equal radical 2 over 2. That means this 45 is also correct. Again, you can check 225 on your own. That will be a correct answer as well. And I'm just going to write the solution set here so that we get used to it. So our solution set is going to be 0, and I'll write them in incrementing order. The order doesn't matter when you list them, but just because you'll see it more commonly written this way, I'll write it in increasing order. So 0, 45, 180, and 225. Questions there? Okay, part D is tan squared plus tangent x minus 2 is equal to 0 over the interval 0 to 2 pi. So here we are no longer looking for a degree answer, we're looking for a radian answer. Now again, it might look a little intimidating, but let's say that tangent were y. then this is the equation y squared plus y minus 2 is equal to 0. And we already solved that equation in the warm-up. In the warm-up, this was part B, y squared plus y minus 2 equals 0. And the answers that we got were y equals negative 2 and y is equal to 1. So I'm going to transfer over that work here. Okay. So this had answers y equals negative 2 or y equals 1. So that we don't redo all of the work. We've already done that. And so we said if a tangent is represented by y, and y is equal to these numbers, that means that tangent of x has to be equal to negative 2, or tangent of x has to be equal to 1. And I'll write here C work, C algebra work. From the warm-up, part C. Is that okay? Do you guys have questions? Now, what this means then is we're trying to find all of the angles x that have a tangent equal to negative 2. Now, this negative 2 is not something that we're able to form by doing y over x with any of these points on the unit circle. So what that means is that we're going to have to rely on our calculator to help us out with that part. And so what I want to remind you of, because this is something we haven't done in a while, but in the calculator, if I try to isolate the x by taking tan inverse of the right-hand side, so meaning tan inverse, I would need to take tan inverse of the positive first of all, and that is going to return a reference angle. Okay, so here I'm going to write this is the reference angle. Now, take the calculator and I'm going to check that I'm working in radian mode. Then I'll take tan inverse of 2. And that is approximately 1.1071. But that is only the reference angle. It doesn't mean that it's going to solve our problem. We now have to use that reference angle to find the actual angles x that satisfy this. So let's think about it for a second. This angle x has a tangent that's negative. So in which quadrants do we have negative tangent? The question is, where?
And
Quadrant 2 and quadrant 4.
Very good. Yes, quadrant 2 and quadrant 4. And how do we know that?
Because of the y over the x of the axis, the flip of them.
Yeah, very good. So it means that the y or the x is going to be negative and they're going to be opposite signs, right? So like for example, in quadrant number 2, the x is negative, but the y is positive. So when we have y over x, we'll have a positive over negative, which would be a negative tan. Very good. And then in quadrant number 4, we have a positive x and a negative y. So again, if we do y over x, we're going to end up with a negative tangent. Okay, very good. So that means that we're going to have two answers. One of them is going to be in quadrant number 2. And let me draw the diagram for quadrant number 2. Okay. So again, this is our quadrant number 2, and we're saying there is an angle that is called x that terminates there that we want to know the measure of. And we only know the reference angle, which is found here. Right? So based on this diagram, if I want to find out what is x, what is the equation that I would want to use for it? X is equal to what? I guess I could write it. What would be the equation? How would we get the value of x if we already know the reference angle? These two angles add up to what?
You subtract it from 180.
Very good. Yeah, you subtract the reference angle from 180. So in since we're working with radians, we would do pi minus the reference angle. Right? Because if together they make up pi, right? If together this is pi, then to get just the x, we would take pi and subtract away the x bar or the x hat, which is our reference angle, and be left with the x. Very good. All right, so the first angle is going to be given by pi minus this 1.1071, which was an approximation. To keep it more precise, we can use the original tan inverse of 2 and punch it into the calculator. So let's see what that gives us. I have pi minus tan inverse of 2. That'll give us a 2.0344 approximately. So that's one possible answer. The other one we said would be in quadrant number 4 because that's where tangent can be negative. So repeating this process, but for quadrant number 4 now. I'm going to draw the diagram. We have an angle that terminates in that quadrant called x that we do not know the value for, but we did find out what is the reference angle x hat. So what is the equation in this case for finding x?
Do you subtract it from 360? Or
Sorry, can you repeat that?
you said the value for x or
Yeah, for x, what's the equation that we would use to help us compute x here?
okay.
Because these two together, they add up to one cycle, right? Which is 360 or 2 pi. Yeah, thank you very much. So I have a private message that reads 2 pi minus the reference angle. Very good. Minus the reference angle, which is x hat. Because remember, this is one cycle, which is 2 pi. If we take away the reference angle, we're left with just the x. Okay, so very good. Again, we can replace the x hat with the 1.1071, but since this was an approximation, it's going to contain a little error. So I'd like to just put in the original value of tan inverse 2. Okay, so that means that I'm just going to insert, oops, I'm just going to insert a 2 in front of the pi to get 2 pi minus tan inverse of 2. And that gives us approximately 5.1760. For x. Okay, so that's for this first equation, x is equal to x is equal to, sorry, I'm saying this totally wrong. Tangent of x is equal to -2. Okay, we still have another equation. Tangent of x is equal to 1. Now, thankfully, this is something that we do find on the unit circle. And in fact, we had to find what those angles were in degrees for the previous problem. So we can just look at those answers and then translate them to radians, right? The first angle was at 45 degrees, which is here. That's where we have y and x are the same. Therefore, tangent of that angle will give us 1. And in radians, that's a pi over 4. So for this one, we get x is equal to pi over 4. The other possibility was when theta was 225. So at 225, we have radians of 5 pi over 4. So those are the 4 answers that we get that satisfy this equation. You can always plug them back in to check. But because of time, I'll let you guys do that on your own. Okay, so if we were to write the solution set, we can start by listing out the radians. So pi over 4, 5 pi over 4, or I should say the radians of all big pi. Then we'll list out these. So it's 2.0344 and 5.1760. Sorry.